But let's start with that question. Who of you is a gamer? So who plays regular games? Okay, I see quite a couple of hands up there. Maybe a question to the room. What kind of games do you like?
RPGs, The Witcher, Alien.
All right, cool. So let's not go into that discussion right now. My top games are these. So I like to play mostly indie games. The first one is Stationeers, and I like this probably because I'm a nerd. And I always see the nerd factor of this. So for Stationeers, for example, I learned how to do assembler code. Great resource for this. For City Skylines, it's a great building game. I learned how to do proper planning ahead. And for Factorio, also a must play from my point of view, I learned how to do proper modularization. Anybody knows any of these games there? Okay, yeah, cool. Still a couple of hands here. So much for the moment about games. We'll getting back to that topic later. So Stephen explained already a little bit about what we do at Tilo, and I'm talking about one specific part of this, which is the geomatching. And when you, for example, want to do some kind of entity linking, let's say you want to do entity resolution, sorry. You want to, for example, match people with each other, or data of people, and find out what kind of data belongs to the same person. You have to find out, for example, okay, is the name similar or is it even the same? And also, do you have different data points, so addresses which are relatively close to each other? The general question is, for example, in this case, do these three records belong to each other or not? Ideally, you have some kind of coordinates, and then you can do some kind of distance matching. So, for example, if you're taking the Alexanderplatz here from this one, it's quite simple to say, okay, please give me all. Well, it's not actually simple. That's a whole topic about it, but to make a radius around this address and try to find all the addresses which are around a 5 kilometer circle, for example. If you're using maybe a traditional relational databases, a simple query like this would be sufficient. So you're just creating some kind of a bounding box, and you try to find out all the records which somehow match in it. The performance depends a little bit. The more data you have there, it's getting slower. It's also a question if your database even supports something like this. Probably if you're using some kind of key value store, or you don't even have a database at hand, this will not work. So what can you do? Well, you can tile the world. So for example, you can do a very simple grid onto that world. In this case, it's a latitude and longitude grid. We are just doing some kind of take the first three fractions, for example, from the latitude and longitude value, and based on this, we're creating automatically a grid, and we can then, for example, tell that this tile here has a specific ID, and we can search directly in our database with that specific ID. So what's the issue with that kind of grid? Well, if you're looking closely already, you see it's not perfectly square, which is of course, you will never get a perfect square grid on a sphere, but it's not even close to being a square. And if you're looking at other cases, so for example, we're looking at addresses around Nairobi. You see, okay, this Nairobi is close to the equator, so it is actually almost square. While if you're looking at the nice little town of Rovaniemi in northern Finland, close to the polar circle, you see, okay, this is not square at all. So why is it a problem? Well, if you're trying to find all the possible entries within this 5 kilometer radius, you do have to make a lot more requests to your database in the case of Rovaniemi than you have to do in case of Nairobi, which has an impact on the performance. probably you don't want to have this kind of impact, because why should a request to a database be slower if you're searching further in the north while when searching close to the equator? That kind of is ridiculous, and you don't want this. If you have, for example, a database like DynamoDB and you use a pay-per-request model, it gets even worse because you're paying more for that kind of searches. So what's the idea? No, just one thing about this. The reason for this is obviously clear. The longitude lines, so the ones going from the North Pole to the South Pole, or the other way around, they're getting closer towards each other, and therefore, of course, the distance between each other gets smaller and smaller. So how does a perfect solution look like? Well, that's a so-called Goldberg polyhedron, which is basically tiling the world into hexagons and a couple of, I think it's 12 pentagons. So the nice thing about this is they are all relatively the same size. Obviously, the hexagon's not the same size as polygons, but pretty close to each other. And you can tile the world in this way. However, I personally am not a math genius. I can't do this math. There are people out there who can do this. I can't. So, for example, if I want to see, okay, please give me the ID of this one, and then give me the neighbor ID of this one, I wouldn't know how to calculate this, to be honest. Maybe you're smarter than me. Maybe you can do this. It's complex anyway. Surprisingly, there are actually libraries out there which can help you for this, which is the Uber H3 library, which does exactly this thing. They tile the world completely into this kind of grid. And yeah, you can use it if you want. For most situations, however, I think it's too complex, and also the calculation is a little bit more complex, and therefore it's a little bit slower again. Back to the gaming, there's a nice game called RimWorld, which also uses this kind of grid. You unfortunately can't see it in this kind of picture here, but if you scroll or if you zoom in further, you see, okay, the whole world is based exactly on this kind of grid. Which leads me to another great game, which is Dyson Sphere Program. And the interesting thing about this is, besides its great concept, is that they're using a very unique grid for doing the tiling part. So that's a very plain view here of one of the planets in this game. And what you can see here is are the green lines. And these green lines are basically dividing the whole sphere into 4 quadrants. And then you see the blue and the red lines, and these are kind of comparable with normal latitude lines. So they always have the exact same distance between each other. But on the other side, so what usually would be the longitude lines, you see the yellow lines here. And some of them, they're almost going straight through, while others, you see some kind of zigzag curves here. And in general, you can see, for example, here in the North Pole, we have actually per quadrant only one tile, which is then divided into 5 subtiles. While on the equator, for example, they use 50 tiles 50 blocks per quadrant. Meaning you have 50 times the blocks following around it. And yeah, it creates a quite nice grid, as we can later see. Here's just a close picture of this, where you actually see, okay, within these blocks, there are further subtiles, and all these subtiles, they are always 5 times 5 squares. This can, of course, vary on your needs. So you can also create a subtile or subdivision this one into, for example, 100 tiles or 1,000, whatever makes sense for your use case. But the interesting part is it's always like this. And all these subtiles are almost perfect squares. Not exactly, of course, also the further up you go, you see, okay, for example, here we have a tile that's twice as big as these tiles here, but in general, most of them are relatively the same size. So let's apply this to the actual world. So first of all, we're adding all the lines, or all the latitude lines where so-called belt switch happens. So sorry, I forgot the naming here. This one I'm calling a belt, and the belt switch is always when you have the zigzag curves here. So we're adding all the lines with the belt switches. Then we're adding all the other belts in here. And the last thing is, of course, we can also create the actual blocks out of it. Don't let you fool. The tiles here in the north look bigger than they are. That's just because of the Mercator projection. In fact, also these tiles here in the top are pretty much the same size as these in the bottom. The nice thing about this is it's super easy to work with. So for example, if I have this tile here, I can easily, this one has an ID and I can go to the right and I know exactly the ID of the other one. The same one I can go to the top and it's also simple addition, in this case on the y-axis. Gets a little bit more complex here when you have actually the belt switch, but it's not that complicated. Of course, we can also further go into this and create some kind of subtiles there. This case is, or in this case, it's close to Copenhagen, and here you can see in detail how this kind of belt switch looks like. However, even here you see, okay, sometimes you have longitude lines which go completely through it. So how is the master looking for this? I'm not going to into detail, but if you're looking at it, the most complex one here is how to do a floor calculation. Everything else is just plus and addition and division. So it's really simple to calculate this. For example, we can calculate this kind of tile ID, which is below here, for the coordinates in Alexanderplatz, and that's pretty simple. So how does this grid look like at the equator? Well, surprise, surprise, there's basically no difference. But let's look at the case in Rovaniemi. So on the left side you see the standard lat long grid, while on the right side you see the Dyson Sphere Program grid. And here's the big advantage. So in case of Rovaniemi, you would have to make all these all queries for these kind of tiles here, while the amount of queries you have to do in Rovaniemi is exactly the same as we saw before in Nairobi. So that's a pretty huge advantage. Of course, you can also, as I said before, you can change the resolution, so you can have more tiles, and yeah, in this case, you don't have to do so many calculations, but of course, in this case, of course, it's more queries again you have to do to your database. So it kind of varies about finding the right resolution for your use case. Any questions or game recommendations? The last point is, of course, more important for me.
One question. So the parameter is the resolution, but the resolution happens like the belts are fixed. Kind of you have only this like amount of belts, and then it's the resolution you want to work with.
Exactly. Okay. So it's basically this grid which is kind of fixed, and then within that grid you have a resolution which is then simply taking this block and putting n tiles on it.
And have you looked at like having belts that are from the bigger resolution, like more belts? Does it bring anything? Because then I guess it brings more.
Yeah, sure. You can easily do this. This one right now follows really the exact same grid as it is done in Dyson Sphere Program. But if you need more flexibility, you can easily change this. As you can see here in the master, this is basically a long list where by default there are 100 blocks in Dyson Sphere Program, 100 belts, and each belt defines how many blocks are in that belt. but that's completely up to you how you can easily change this one.
There was a question online, how can the technology be used?
Yeah, well, for example, we use it very concretely in Tilo for doing geomatching. So we are actually using DynamicDB, and since DynamicDB is most efficient if you're just searching for a specific key, you can, for example, have a key which has the tile ID plus a name as an example. Then we can do very quick searches with given that to find our results. There are probably a lot more applications for this. So whenever you want to do some kind of geomatching, it's applicable. The only thing which doesn't work so well is really the last 3 degree approximately on the pole region. So that's something where Goldberg polyhedron definitely is much better than this one. But yeah, there's fortunately not so much going on in this region.
To summarize, so basically these two are using a database, a spatial database, which allows for this, should make any queries to this database more efficient, right?
Yes, exactly.
That's the summary, right?
Exactly.
I mean, my question again, probably similar to that one, like how does, it seems like such an important thing, you know? Like, is there like some database which exists, some open source which takes account of this? Is there like, because it's a gaming company which is creating this, you start to think about it together.
I'm honestly not even sure how spatial databases do this. For example, I know that I forgot the name of the database. The other one, big one next to MySQL, Postgres. Thanks. Sometimes does have a geospatial support, but I unfortunately don't know how they do it. I also honestly couldn't find a proper name for this kind of a grid. So if anyone knows how it's actually called.
Is it like GIS or something? I've heard that bandied around with this kind of thing.
There are honestly other grids, but none seem to be exactly like this one. So I am honestly not sure if there are any kind of existing solutions for this.
I know in Elasticsearch you can do geo-matching, and in Elasticsearch, so the whole point of if you index a text document in Elasticsearch, you need to do tokenization. So you need to split the text in tokens, and I think they apply something like the same idea for geo. So then you tokenize the geo, and then there is some kind of grid that is applied, and then you sort of index by big block, small block, small and smaller block, and then you can query by the blocks. But I don't think they use like. I think they
yes, it sounds like some kind of a hierarchical grid, which I also know that they exist, but they form a little bit different again.
It's more like the first thing you mentioned with the latitude, longitude, and then you just index like kind of these big squares.
Exactly. Exactly.
Any more questions or
game recommendations?
I always recommend multiple. You know that already.
Don't take Factorio, it feels like work, you know?
Yes,
Factorio, I feel like I'm working.
I started and it got too stressful, like I cannot do this anymore.
Have a great office.